conniptions throughout the 1980s. Turns out he was right. Matter, until it's observed, is a tendency to exist. It's a probability distribution. And when you take quantum physics in school, you calculate expectation values. So, then we're now in the 30s. Einstein gets together with Podolsky and Rosen, and they say, this is the first formulation of, or the statement of spooky action at a distance. Now, what is happening here is called entanglement. Entanglement is when you have, an atom produces two electrons, and they hit something and go flying in opposite directions. You say, well, this electron can be facing up like this, and this one facing down. Those are the two ways electrons can be. Spin one up, spin one half up, or spin one half down. So, but no two atoms, no two electrons can exist with two up in the atom. So coming from the atom, there had to be one up and one down. So then, this one goes flying off, and if they don't exist as particles till they're measured, then measuring this one forces that electron to be either up or down. But that means that if you're over here measuring this one should then consequently, since it didn't exist before, appear to be down or up. So if you measure this one, and then you can measure this one real quick, faster than light could have communicated it, then you've made an electron here, and you're making an electron here faster than light could have communicated that its pair electron was made. Something said, hey, I'm an electron now, I'm not a wave anymore. Pew, so am I. And according to the equations, it's instantaneous. That's called spooky action at a distance, and it turns out that that experiment's been done, and that's exactly what happened. Einstein thought this proved that quantum physics is too weird to be real, to be true. Even though he had a part in founding it, he didn't like the formulations that were happening. But it turns out he was right. He predicted this spooky action at a distance. He just concluded it was ridiculous. It was the second mistake Einstein made, where he thought he was wrong and he was right. The other was that the universe is accelerating. He added a cheap factor to get the universe to be stable. And it turns out that it was expanding. But anyway, that's another story. Well, that'll be the astrophysics, not the quantum physics. Now, David Bohm comes along, and he says that he basically quantifies faster than light underlying connectedness. And that's a major contribution, because in the 50s, it kept this weird quantum aspect alive. Does all this weirdness keep people from designing computers and electronics and all? No. What were you told? You were told how to calculate the Schrödinger's equation. Yeah, but what about Bohr? Don't you think complementarity? I had an instructor that said that. It's basically, he said, shut up and calculate. It's like, don't worry about the weirdness. I mean, they pretended it was an embarrassment. It'll all get ironed out in time. Well, it turns out that in the 90s, suddenly the spooky action at a distance can be used to make quantum computers. And quantum computers are remarkable possibilities. And suddenly, engineers, everybody's getting interested in spooky action at a distance.